So in this video, I'm going to go through a couple of examples of how to balance more complicated redox reactions. Before I do that, I want you to pause the video, and I need you to print out some instruction sheets, some rules for balancing. There are two methods of balancing, half reaction and oxidation number. On the website, there is a handout that's titled Rules for Balancing Redox Reactions or something to that effect. Please pause this, print those out, take a few minutes, look through the rules, read through the examples before you turn this video back on, and we go through some examples. I'm not doing the ones that are on the handout. I'm going to do different ones, so you'll have a couple of examples to practice with before we get into class. All right, so pause the video here. So you've paused the video, you've looked at some examples and so forth. So now what I want to do is go through and do some examples for you. So this first one, I'm going to balance in acid solution, and I'm going to use the oxidation number method first, and then I'm going to show you the half reaction number method second. It does not matter to me which method you use. AP will sometimes specifically ask for one or the other. If it asks for one, more often it asks for the half reaction method. So keep that in mind. Make sure you're comfortable with both ways, just to be safe for the AP exam. All right, so here's the reaction. You look at this, and the first thing you think is that there is no oxygens on the product side. How am I going to balance this out? Well, what you're looking at is kind of a skeleton to the reaction. And so in order to balance oxygens and hydrogens and hydroxides, what we wind up doing is using water, because obviously acid-base reactions have to take place in the presence of a lot of water. So that's how we're going to wind up balancing everything out. So the first method that I'm going to do is balance this via the oxidation number method. So what we want to do first is assign oxidation numbers to everything. So hydrogen is always +1, but there's a total of 3 of them, so I'm going to call this a +3. Is that big enough for you to see? Hopefully. Oxygen, unless it's a peroxide, is going to be -2, and so that gives me a -8, a +3, so that means AS must be +5. Zinc elemental is going to be 0. Here, now we've got hydrogen being +1. AS is now going to be -3. So it's changed from +5 to -3. Zinc is now +2. So once again, zinc has gone from 0 to +2. So what I like to do is just kind of connect the two things. So I know that AS is one of the substances and ZN is one of the other substances. So now what I do is I take a look and I think about, okay, how many electrons are changing? Well, I'm going from +5 to -3. That's a total of a gain of 8 electrons. So I'm just going to jot that down to keep that in mind. In this case, zinc is losing 2 electrons. So it's -2 electrons. Now, the first thing I need to do is I need to make sure that the electrons balance. So I'm gaining 8, but I'm only losing 2. So I'm going to have to multiply this zinc by 4 in order to account for the fact that I have to have a total of 8 electrons switching. Okay, so now that I have my electrons balanced, now I'm going to go and I'm going to balance atoms. Well, zinc's balanced, AS is balanced, even hydrogens are balanced at this point. What I don't have balanced is the oxygens. So there's 4 oxygens on this side. Since I'm in an acid solution, I'm going to balance this with H pluses and water. So since I'm short 4 oxygens on the product side, I'm going to add 4 waters to this side. Okay, now that I have 4 waters on this side, I've unbalanced the hydrogens. I used to have it balanced, but now I have 8 hydrogens over here. So I'm going to add, this is going to take, like I said, this is taking, whoops, not electrons, hydrogens. This is taking place in an acid solution. So I need to add H pluses in order to balance out the H's. And so now if you count atoms, everything's balanced. We've already balanced electrons. So that's how you balance a reaction using the oxidation number method. So what I'm going to do now is switch gears and show you how to do this with the half reaction method. So once again, I'm going to focus on what's changing oxidation numbers. So if you take a look, I'm just going to bring down what we had already written up top. So I know that AS and zinc are changing. So I'm going to write the 2 half reactions. So I'm going to write H3ASO4 going to AsH3. And then the other half reaction is zinc going to zinc 2+. So now the half reaction method asks me to first balance each half reaction by themselves. So doing the zinc one is pretty easy. I can add 2 electrons there to balance that half reaction. So you kind of have learned the half reaction method already because we can use it on the really simple things. All right, so now to balance this, all the atoms are balanced, but I have to make sure that I can now balance the atoms. So 4 oxygens here means I need 4 waters on the other side. Now I have 8 oxygens, or 8 hydrogens rather, that are not accounted for, so 8 H pluses. Now my final step is to balance electrons. So I have a total charge of 8 plus here. I get a total charge of 0 here. So I'm going to add 8 electrons. Can you see that? Sure, a little far. So now I've got the 2 half reactions completely balanced. Now I need to combine them. So to combine them, remember that electrons need to cancel out. So this whole reaction has to be multiplied by 4. So then I get 8 electrons and 8 electrons, so they'll cancel out. So now I can simply add those 2 things together, and if you need to add them together completely first before you cancel everything out, that's okay. I actually am going to jump right to the overall reaction. So I've got 8 H pluses, I've got 4 zincs, and I've got an H3ASO4, and then I've got AsH3 and, 4 zinc ions, and then 4 waters. So if you take a look, this is actually the same reaction that we wound up. Can I get it all in one shot? Go up a little bit. So I've got the same result, simply 2 different methods. So I'm going to stop this video here. We'll do the balancing in a basic solution in the next video.